One of the biggest things that I hope the customer always remembers is that we care. We care about what they do. We care about their mission. We want them to make that mission just like they do.
I'm Teresa Hitchens, and I am here today at the BAE booth with James Miller to talk a little bit about their robotic technology demonstrator, which is a pretty cool looking vehicle. James, you want to tell me what you guys are doing with this?
Sure, absolutely. We've got, we'll keep it short. We'll call it the RTD, but the Robotic Technology Demonstrator. Pretty excited to showcase this. As you know, the Army's looking after the Army and trying to go after the next generation of combat vehicles. Really vital program they got going, one of the priorities the Chief of Staff of the Army set. And so inside next-gen combat vehicles is a robotic combat vehicle. And everybody sees robotics as a wave of the future. It's really important on the battlefield. We see and we're really excited about it because we're talking about taking a soldier out of harm's way, pushing robotics forward where soldiers used to be, and using those robotics to increase the effectiveness, the lethality of the Army unit, and it's really, really exciting. So the RTD is our way to get after that next generation of capability in robotics in ground combat vehicles.
So can you tell me some of the types of technology you're testing on this platform? Because it is a test platform, so I assume that the different components are each being tested kind of separately.
Yeah, it's pretty amazing. We call this our rolling lab, and the idea is it's a vehicle to experiment on, and it runs, and you can drive it around, and you can try all the technologies separately, but the critical piece we're finding out is how do they integrate together. And the integration really is giving you the leap ahead. There's a lot of value in something like a sensor, but when there's 2 or 3 sensors that are all slightly different, it's amazing the integrative capability you can get out of that. And that's really where you go. The math changes from 1 + 1 to it goes crazy exponentially. It's amazing. So our engineers love the capability we've given them with this. But the idea really is a rolling lab, and the sensors we have, so there's sensors that just look and help the vehicle drive on its own. So it can be autonomous by itself, driving. And then the remainder of the sensors help the vehicle be semi-autonomous, because we want a human in the loop whenever we do something lethal. And so we've integrated this great suite of sensors. They all talk to each other. They all do different things. Some of them are short-range sensors, long-range sensors, like the way we have the mast. We've integrated an unmanned aerial system on a tether behind it that allows you to get altitude and see things from a different angle.
So the sensors on the UAV?
There are sensors on the UAV. And on the back of the vehicle, we have a Marsupial Robot. So a robot that rides on the bigger robot, and it's on legs, 4 legs. And that legged robot is there to, when you have a manned vehicle, you dismount soldiers to do dangerous tasks. It's like, I'm not going to risk the whole vehicle, go look at it. We don't want to do that with soldiers anymore, so we have a robot do another robot's work, right? So it's really cool. We've got hybrid electric drive on this vehicle. So the thought is we have this great hybrid electric drive system that we put in our commercial buses. And our commercial buses are everywhere. There's thousands of them out there. They have millions of miles of reliability all into them. They're very mature systems. They're perfectly suited for this. Moving back into a combat vehicle like this, the vehicle's quiet, super quiet. It's got excessively long range because it doesn't need a whole lot of fuel anymore. And where we used to have soldiers to take care of things like tracks and things like that, you don't need them anymore because we've put composite rubber track on, very low maintenance, long range, and it further reduces the need for power and energy and fuel. So all that tied together, you start getting an idea of what's in the future that's real exciting, could be pretty amazing. And the set of technologies on here are current technologies, right? Like the 30mm gun, pretty current. We got room for other stuff on either side of it. What is that other stuff? What do combinations of other stuff do? As we discover new technologies from teammates and partners in our own company, how can we add that on? And we're seeing inside our own company huge value in, we've done this in the air and space domain for a long time. How do you apply that to the ground and what do you gain from it? That's the question we're trying to answer with these rolling labs, so we can see what we can do for the Army.
So one last question. The Army is going to have a contest relatively soon on unmanned vehicles. And is your goal to develop your own vehicle to compete, or is your goal to sell bits of the technology to the Army separately, or maybe it's both?
We've offered a vehicle to the Army, and our goal is to keep developing this vehicle. And the idea is, how do you make it better and better? How do you reach ahead? And then the other cool thing is, what technologies on this vehicle would work well on some of our other vehicles? And how does that help the Army? So there's a lot of paths for this experimentation, this testing, this integration. It's going to be fun. It's going to be exciting. The good news is it's going to pay off for the soldiers on the battlefield.
That's great. Thank you so much for your time. I really appreciate it.